Hey everyone, welcome back to MLWorks. In this video, we'll be discussing how to build a chatbot with memory. So we know how to build a chatbot with LLMs, but most of the chatbots are simple and they don't retrieve the previous conversation effectively. Okay, so what we'll do in this video is we'll be building a chatbot which will be capable of accurately fetch the information from previous conversation if required. Okay. So we'll answer some of those questions in this video and we'll try to implement the chatbot with memory. Why do we need memory in the first place for a chatbot? Okay, so LLMs are stateless. Considering if you are passing an input to the LLM, it will give you the response, but it won't remember what was the first query that you have sent. Okay, so that's why we have to store that responses as part of your chatbot, such that if a question comes up, next question comes up, and it has to look back, then it should be able to fetch it from the memory. So what we'll do is we'll build a system where we have all the previous conversation from a user stored into the vector store, and which will help you to give more relevant and personal answers to a query given by the user. And when you have memory, so we can also avoid being stuck in loop. For example, I have worked on Dialogflow, so I have seen where if you pass a question, there is a very good chance if the model is not able to understand, the LLM is not able to understand, what it will do is it will keep repeating the same questions which you are sending it. Okay, you can avoid that as well with the memory. Now what we'll do is we'll use a tool called Mem0, which is an open source tool for storing the long-term memory. Now this will also fix an issue which comes up with LLMs, which is when you train an LLM, it has a fixed context window beyond which it cannot take in as the input. So when you have memory in place, what you can do is you can take the previous conversation, summarize it, and put it as part of your prompt. Now the way Mem0 works, it tries to extract, consolidate and retrieve the salient information from ongoing conversation. Okay, those key process is split into 4 steps. The first is, given a conversation, identify the important points, summarize it, store it in the vector store. Now what will happen is whenever a new conversation starts, it has to fetch the relevant previous conversation also if required. And when you are talking about a certain conversation which requires to look back the previous conversation and requires to update the previous conversation also, then it is possible to do with Mem0. And for doing all this search activity, right, so we'll use something called as vector similarity to fetch the relevant passages and to generate the response. Okay. So with that, we'll start with the first notebook for understanding how the setup works. That is the chatbot with memory. So let me go to the top. So one thing I have to mention is I am not going to run this notebook because I'll be using Gemini Flash 2.5, and each of these requires you to make an LLM call, and which requires token, and you also need if you have the money to purchase the premium subscription, and then it's fine. Otherwise, I'll just use the free version here, and so I'll avoid making LLMs calls because I already made it. So first, what you have to do is you have to install Google's GenAI package and Mem0. Okay, once you have installed that, you can import it, and then we are loading .env, which stores my API key for Gemini. So I'm loading it using load.env. So this is where I'm loading the API key. Now this environment is set for the API key. Now what I'll do is I'll just create a client for GenAI, and this will help you to reach out to the Gemini model in the backend and try to make the LLM call, this client. And I'm also setting up the config for the memory. Okay, so that memory will be using couple of models. One is the embedding model. So one thing I have to mention is we are storing the passages, so it will be stored as part of quadrant vector store in the backend. So we have to turn our text into embeddings. So for that, we'll be using text embedding from Google itself. This is for generating the embedding and storing it into the vector store. Then comes our LLM, and which will basically summarize and understand your conversation. Okay, so for that we are using Gemini 2.5 Flash. And one of the config is for vector store is what is the embedding size, which is 768. Once the config is done, we pass this config to the memory, which is the Mem0's module. And from config, we pass this config. We want to use two models, and these are the corresponding configuration details. Now, you have created a client and you have a memory. Now, what we'll take is, we'll take sample conversations. This is conversation 1 by the user, and this is conversation 2 by the user Philip. This is conversation 3 by the user Philip, and this is by Mark. Okay, so this is a conversation history, and what we do is we add it to memory by dot add following the conversation followed by the user ID. Similarly for conversation 2 and conversation 3. Now each of this conversation talk about certain topic. Okay, we'll understand that later. So what I'll do next is, since we have created conversation, we added that to the memory. What we do is next we search through that memory and we pass this query, what do you know about me? The user ID is Mark. Now what it will do is, in the backend, it will understand this question, the LLM model, okay, and it will understand the conversation that has happened here, and it tries to answer this question from this conversation. Okay, so let me run this here, and if you see here, you will see for MN related memories, it will there are a bunch of results come up, and we'll just look at the top 3. So it will give you the corresponding result for this specific query. What do you know about me? You are a professional background, you have a professional background, and then you have read this book and you are interested in the goldfinch. So this is related to the user Mark, and if you see, it refers to these kind of topics here, goldfinch, and it talks about reading, okay, a bunch of stuff. So it is able to go back to the conversation, understood it, and for this it responded. Now let me delete this one. Okay, so now let us understand what happens when you have a prompt with memory and without memory. So here you have a system prompt, and you are saying you are a helpful AI assistant, and I have a prompt here, and where I'm asking the LLM to generate a title and a key visual for the upcoming conference, and I'm also adding, I'd like to certainly connect it to my personal interest. Now this is something closer to the user who is sending the LLM call or making the LLM call. So it has to add those personal interest information. Now when you directly just pass this prompt and the system prompt, and it will generate a response like this. Okay, it gives you certain suggestions for the interest, and at the end, if I just look at here, it is asking you, the user, to send the personal interest such that it can generate the title and the visual imagery of the conference, whatever, right? So it will try to generate that based on this, your personal interest. So what we do is, we have a prompt, okay, and then we have our helpful memories coming from when we send this prompt. Okay, for this prompt, what are the corresponding results, right, for this specific user? Okay, for this corresponding query, what are the specific results? It will come up and it will become your helpful memories for this specific question. Now what you do is, this memories becomes your part of your system prompt. Okay, so what we do is we combine all the memories here and then pass that to our system prompt, and this is how the memory looks like for Philip, and for this question this is the memory. Okay, now once you have extended the system prompt by adding the helpful memories, what you can do is next make an LLM call with the extended system prompt and the same prompt which we used here, we use the same prompt and then extended system prompt, and then finally generate the title and the details about that conference. Okay, so if you see the response now, the brainstorming titles, it will try to include the personal interest of the user into their title. Okay, for instance, Beyond the Horizon, Agentic AI and the New Enterprise Frontiers. And it will look into this specific point also, high vantage point, so like a summit. Okay, so again, if you see some other options as well, you will look at autonomous is ascent, and again ascent like a climb. Okay, so what it has done is, based on the personal interest of the user, okay, and the question that was asked in the prompt, it tries to generate the titles, okay, and the subtitles or whatever, right? So it is able to understand those aspect of the prompt and able to generate correspondingly. Okay, now this is for a simple chat. Now we'll try to create a chatbot with this notebook. And I talked about the process earlier, where we have messages and you try to extract the key information and turn it into a summary and then store it into database, which is in this case Quadrant, and we are using LLM model like embedding model to store it into vector store. And whenever the conversation is happening, it will look into the previous conversation and update the memories if required or delete if required. Okay, so that's the whole thing here. Now what we'll do is we'll again go back to how to create a chatbot here. So it is simple stuff again. So what we do is we just load the packages and then we import the Gemini API key again. We create a client, GenAI client, which will help you to connect with the LLM. And then we are setting the configuration for memory. First is the embedding model, then LLM, then vector store. And again we create our memory from here, from config. And you are mentioning here as part of your system prompt that you are an helpful AI and answer the question based on queries and memories. Now, there are two functions here, chat with memories and main function. And here in chat with memories, since it is memories, it has to look back. So we have something called as history, and then there is corresponding user ID. Now this will fetch the relevant memories, okay, and create a string, and it will become part of your system prompt. And then history is something that you get from as part of your function call. Okay, so once the response is coming up, that also becomes part of your history again. Okay, so you have to keep track of your history as the conversation is happening. And here if you see, this is where you see the messages that is being piled up, and this is becoming part of your memory again, and we return the history. Now here what we do is we are running a while loop, okay, and you sending some input first, okay, and based on that input it will try to understand the LLM and generate the response. Okay, so first I'm printing this. Okay, so you will see it here, and then so let me go back to the code as well here. So what will happen is I am taking the input. If the input is exit, I will come out of the loop, okay, and it will say goodbye. Otherwise what will happen is it will go and make a call to the chat with memories, and it will converse with the LLM, and it will get the response, and it will keep running unless the word exit is mentioned. So here the conversation starts. I say, how are you? Gemini replies, I am doing well, thank you for asking. So I am saying again, I am good, I just had tea, keeping books at the table and going for a walk. Gemini says, that sounds like a perfectly lovely refreshing plan, and it also responds with, enjoy your walk, I hope the weather is nice wherever you are. So I say back, yes, the weather is good. Okay, then Gemini replies, that's wonderful to hear. Good weather always makes a walk even more enjoyable. Now, have a really pleasant walk. And so that is the conversation. This is the conversation from Gemini till here. Now, what I say is, do you know where I kept my book? Okay, so it goes back. Okay, Gemini goes back to the conversation which I had earlier. Okay, here. Okay, so it looks back and it is based on what you have told me, you are keeping your books on the table. So it has able to fetch that information and send it as a response. So I say yes, thanks, and then that's it. Okay, I exit from here and it is enjoy your walk, and it's nice, right? At the end it also says that enjoy your walk and goodbye. Okay, though it is not part of it actually, so it just says that enjoy your walk and goodbye. Yeah. So this is how the conversation happens. Okay, once you run it like this, okay, it stores all these chat that we are creating. Okay, it stores inside that specific vector store, and it brings it up whenever it is required. Okay, in this case I ask where I kept my book, and it looks back to this specific point and get me the result. Okay, so this is a very important topic actually. So the adding memory to the chatbot is quite important, because going forward all the applications that are getting built with agents or chatbots, whatever it may be, memory is quite important, because there is always a limit on LLMs when it the amount of tokens it can take in. So it is becomes very important you keep track of the memory, or keep track of the prompts or inputs that you have passed earlier, and what was the conversation that has happened. Okay, so that's why memory is quite important, and I hope you understood how to set up memory for your chatbot. Okay, so with that I'll conclude this video. Thank you for watching.